Okay. Today we are going to start about the server architecture. Yeah, last week we have discussed the hardware components of the servers and how we going if we are going to purchase a server, what we need to check or what we need to think about the things we before we purchase in a server and how it's work in the industry level. So today we are going to talk about the architecture and how in here we will discuss about the landscape of those things and the applications which are hosted and likewise things. Okay, so basically server architectures form the backbone of the IT infrastructure, dedicating how computing resources are organized, accessed and utilized. So understanding the server architecture is a uh, understanding of the server architecture is informed decisions about designing, developing, and maintaining the systems. So the server architectures mainly there are traditional server architectures. Then we can talk about the virtualized architecture of the servers, then cloud architectures, among those containerized architectures and microservices and serverless architecture and modern trends in server architecture. We will talk about those topics and the key considerations when we choose in architecture. We need to check about the workload requirements like CPU, memory, and the storage, scalability. It means how easily the architecture adapt to the growing demand. It means the how we can scale those things, the servers. And the main basically we need to think about the budget and the compliance. It means the security requirements like the servers no need to be vulnerable to any sort of security threats, and the performances like latency, throughout puts and fault tolerance. So now we can come to the we will go for the second slide. In here we will talk about the monolithic architecture. Monolithic architecture is a traditional software design model where all components of an applications are tightly coupled and contained in a single code base. Okay, so this approach was historically the default choice for software development and remains in use of many legacy systems. It means that this is the normal server architecture which is used in the environment mostly for the developing side and other legacy systems. Like legacy systems mean the applications which is running over the systems. So next we will talk about the key characteristics of the methodologic architecture. There are mostly we will talk about four key components in here. First one is single code base. In single code base, all applications layers, user interfaces, business logic, and database access are part of one unit. Okay, then changes to one part of the application often require modifying and redeveloping the entire system. It means like this, when we develop an application or something, you mostly there will be updates, upgrades. So the changes need to be taken in the applications or the systems are done in this single code basis. So the second key component characteristic will be centralized development. A single development team manage all aspects of the application from feature to bugs fix, features to bugs fix. It mean centralized development mean uh, a single team. It mean when we think about developing an application or something, there may be so many teams will be gather and do this task. But in centralized development task, key characteristics what happen in a single development team will be handling all the things by integrating features and bugs fixes likewise. Then we will talk about the unified development. Unified development is the entire application is deployed as a single package, simplifying initial deployment but complicate updates. It means when you think about, I think in your campus life or in your courses, you have done developments. Maybe or someone don't know. When we develop an application or something, we can deploy all the application as a one package. Okay, but when we develop as a one package, it will be complicated to update. It means if we develop application by dividing small parts, like front end will be doing by this code likewise, and the back end and this feature this part, it mean the use GUI or the front end or other components will be features will be done by this code likewise. If we do that, it will be easy. It mean if we can develop a small component without the issue and we can replicate it to the system, it will be easy. But if we think about the application with the complete with the one package, it mean if we change something over that package, it will be affect to all other components as well. So that's why the uh, complicate will be happening over that unified deployments. Then the traditional hosting. Traditional hosting mean the typical hosted and single server or cluster of servers running in the same instance. It means traditional way hosting. It will do a basically in a single server. It will be hosted, so the things can be done by it on easily. Otherwise, if we do it like backup is doing in another server, and the components will be run on another server likewise, if it happen, the if anything is going down, the system whole system will be down. So uh, that's the thing. So advantages of methodical ad, architecture is simplicity and the performances. Also fast development for small teams, low initial cost, and so on. So simplicity. Why we are saying monolithic architecture is simplicity? Because it easy to develop and deploy and manage for small applications. Developers can focus on one set of tools, languages, and frameworks. The when we think about the performances, components within the same application communicate faster since no network overload is involved. It means previously I talked traditional hosting. If we have host this application or something or one single component, it will be helping for the performances. Otherwise, the network connectivity with other servers also need to be high. Otherwise, network overhead will be happening in here. So the network traffic will be going in high, then the systems will be slow. They can affect to the slowness of the systems. So that's the advantage of one advantage. When we talk about the monolithic, the performances will be all the performances of the same server will be given to the that specific application or whatever the things we are doing in that server hosting. So the low initial cost. Why we are saying the advantage as a low initial cost? Because for when we purchase a one server, the cost will be very, it mean it will be not a small amount, but the when we think about we need to purchase two or more than servers without purchasing a one server, the cost will be high. If we purchase a one server and we proceed with the monolithic architecture, the cost will be low. Okay, so disadvantages, there are some disadvantages as well. The disadvantage is at scalability, then the single point of failure, and the complex maintenance. And so development cycles, technology, lack of technologies. Because I'm saying like that, scalability is it's a the monolithics are primarily scaled vertically. Vertically mean upgrading server hardware rather than horizontally. It mean vertically mean we can upgrade the things. It means components of the servers. But horizontal mean the number of servers we are adding. So disadvantage, because in here we are using one server, so the scalability little bit low. And the single point of failure, what it means? Single point of failure mean if that main server is down, it will not replicate to other servers, so it will not up and running as we have designed. It means if we design a 24/7 machine or system, if this particular primary server is down, it will be a disadvantage. So then uh, now we can in here mathematical like they are using small applications like user-based applications, mostly post applications like us. It mean for the small business, not for the in the industry. There are two type of things. It means there are small business and large scale business. Small, we are saying the number of systems or number of machines are less, and the large scale mean the resources which are we are using are very high. Okay, so is there any issues? It means the things you can't understand in here. Can you raise your voice and you can ask if anything is there? Okay, so next we will come to the traditional service setup, the root of monolithics. It means the way this happen. Previously I said vertical scaling and the horizontal. We will talk about those things in the future as well. Okay, in here traditional server setups. First we will think about the single server instance. Single server instance, the entire application runs on a single server, managing all its components like UI, logic, and the database. Also the backup and other things, all the things will be integrated in a single server. So there are some examples. We can say legacy ERP system, small business applications. Okay, the advantages of single server instance is simple development and deployments, low initial infrastructure cost, and easier debugging and monitoring as everything is centralized. But the challenges in here are bottlenecks and load increase. It means when there's a single server, the all the request, it means we host an application or we host a system in a single server, and there are so many other clients will be requesting the service from that single server. So the load will be increased. So there are some topic methods called load balancing, scaling. Those will be talk in the future. From those we can handle these things, but in single server instance that will be not available. So and then we can come to talk about the vertical scaling. Vertical scaling is to handle an increase in the workloads. The server is upgraded with more powerful hardware. Like vertical scaling mean we can increase the CPU, RAM or storage or in vertical scaling. So this vertical scaling is relies on enhancing a single server's capacity rather than adding more servers to the environment. The advantages of this vertical scaling is straightforward implementations can be done and no need to modify the applications. But the challenges over this is cost will be high because we need to increase hardware components of the server from here. So also there need to be a downtime because when we increase a CPU or RAM or a storage, we need to shut down the server because these are physical things. So when we increasing these things, we need a downtime because we are shut down in the whole server. So there will be a down in the system. Before going to do any these kind of things in the industry, what we are doing, we are telling or we are marking a mail or we are forwarding us notification to the customer from this time to this time system will be not available. So please be sorry for the inconvenience, something like that. We are informing them we are going to down the system to do this thing, and we are proceeding with the task. Okay, anything you guys need to ask? If not, we will proceed with the next slide. So single server, this the simplicity and the challenges of the single server instance. So the si- simplicity of a single server instance. Okay, so uh, ease of deployment and low initial cost, centralized management, faster development, performances for small workloads. And the challenges will be over the single server instance will be limited scalability because why we are saying small limited scalability, because when we think about increasing the things, the slot which are available over the server will be limited. It means the RAM slots over the machine, it means the server will be maybe 4 or 5 for a server. Sometimes it will be we cannot increase more than 10 slots, it will be limited to 10 slots. Likewise there are things, that's why in the last session also I told you, when you select in a motherboard or something for the servers, we need to think about the amount of slots which are available over the servers. Okay, so the slots available for the storages will be less. So there are some other uh, solutions for this. We can enhance a NAS, or we can enhance some portable devices. Likewise there are so many solutions which are available over this. We will talk about in the future those things. And other challenge is single point of failure. If this server going down, it will be uh, fail in our system. There will be no any backups or something like that. So it will be fail to run the system as designed. Okay, then these things we already also discussed previously as well. I'm just explaining again these things, how mostly in the industry there are no any single server instance recently. It means if for the small business also we are asking for two servers, or what we are doing, we are virtualizing the things in the same server, so it will be having two machines inside the one server. So this is mostly now for the theory, and the other things I am explaining these things because the process, you guys need to know about these things as well, that's why. But in the industry mostly now we are not using single server instances. Next, we have talked about the vertical scaling power up but not forever. So this one, what we have talked about the vertical scaling. Vertical scaling is the setup by upgrading hardware components. It means by adding more powerful processors, more powerful memory, or the storage capacity. So, or we can say replacing this server as well. So advantage of this is of advantages of vertical scaling is simplicity, improved performances, ease of management, quick replacement. Challenges will be limit of resources, which I have already talked. The slots will be if there's less slots, it will be limitations. So the cost will be little bit high, and the downtime, we need to request a downtime, so there will be a single point failures. Likewise things will be happen. So now we will come to the limitations. uh, this has been talked. So then the scalability of the bottleneck of methods. So scalability, there are, we have talked about the scalability as well. I am just refreshing your mind. The scalability works with monolithics like vertical scaling and the horizontal scaling. So risk, we will talk about the risk little bit deep here. Okay. So the single point of failures, mostly main of most thing is, when we think about the single servers, main risk is single point of failure, the risk of the total shutdown. Okay, so we are calling this as SPOF. Sorry, we are calling this as a SPOF. Is an individual component within a system whose malfunction or failure can be bring down the entire application or service. Okay, what it mean? It mean because we are using a single server. If it's going down, everything will be shut down. So why this SPOF architecture is prawns? Because tightly coupled components, all functionalities operate within the same application. A failure in one module, such as a memory leak or a unhandled exceptions, can cause the entire system to crash. If the system get crashed, we need to restore the system. So the if we configure this backup also inside this system, it means in the server, everything will be down. Okay, so we need to we are centralize the resources. Most monolithics rely on the centralized components like database, web services, or application services. So the failure of any of these key components lead to a total server service outage. Then there's a other dependency called shared dependency. So the software libraries or frameworks used by this system is in the uh, affected system. It means the software libraries or the frameworks used are inside this system, or any bug or incompatibility is one dependency can ripple across the application. It means if any bug is happened here, everything will goes down. So next, we will talk about the next architecture. Okay, distribute architecture. Before going to the distribute architecture, is there anything you guys didn't get or any issues within the uh, single server architecture? I think no issues. So we can come to the distributed architecture. At So the distributed architecture involves designing a system where components are spread across multiple servers or nodes or locations, working together to achieve common goal. Unlike monolithic architectures where all functionalities are tightly integrated, distributed and focus on decentralization, enabling scalability, fault tolerance, or flexibility. It means when we think about a distributed architecture, most common thing which is used in industry and other thing, these are still we are talking about the physical on-prem servers. I'm One thing I'm going to say about in here, why we are going to talk about on-prem architectures still, because there are cloud architectures, and it means the industry is having next level of things, and the in technology is now very high, but still why we are talking about this physical servers, on-prem servers, because in the regulations and the rules which are inside Sri Lanka, we cannot go 100% cloud anything. It means in the government, if we are talking about government, we cannot go 100% cloud. There should be single server or more servers physically. There should be, due to some lack of, not lack of, there is, that's the rule and regulation which is still in Sri Lanka. So if you are planning to settle in Sri Lanka, oh, in the industry of Sri Lanka, you guys need to know about the things on on-prem servers. If you are going over the overseas as well, this is the beginning. This is the basic. This is the foundation of servers. So on-prem thing, you need to understand the architectures. You need to understand these same architectures will be replicated to the cloud. Okay. So now I will talk about the key characteristics of distributed architectures: decentralization, scalability, fault tolerance, resource efficiency, and uh, so on. So, what is decentralization mean? Components operate independently and communicate over a network rather than relying on a single server. It means uh, this is not a centralized one. The system is decentralized. The components will be moved to other servers. It means the database is on another server, and the GUI thing is in another server, and the services are run in another server, backup will be doing in another server. Likewise, the operations will be decentralized from a server. So scalable. Next one will be scalability. What is scalability? Scalability is systems can be scaled horizontally by adding more nodes to handle the workload. It means if we request everything to a one server, the workload will be high. If the request of those things will be divided to other nodes, the workload will be little bit low. So that's why we are introduced the scalability. Then we will talk about the fault tolerance as a key characteristic. What is fault tolerance? The failure of a single component or node doesn't lead to a complete system failure, as responsibilities can be redistributed. It means if we have divided the things over different servers, different nodes, if it the service will be down, this but still system can be run from the cache, or the all database will be down, the this will be running without a issue. If the backup is down, not an issue, it has been done in another server, the system can be done run without any issues. So the next one will be resource efficiency. Resource efficiency means workload are distributed, reducing bottlenecks and improving overall resources utilization. Okay, what are the type of distributed architectures which is held in the industry? We can talk about client server architecture. It means the structure which is clients request service or data from centralized server. Use case, web applications or email systems. Limitations mean centralized servers can be become a bottleneck. So peer-to-peer case architecture is there. Then service oriented architectures, it means SOA architectures are there in the industry, and the microservice architecture are there. The event driven architectures are there in the industry. Also serverless architectures are there. Serverless architectures mostly we are saying cloud. Mainly cloud is a serverless architecture. So the what are the advantages of this distributed architecture? Scalability is high, fault tolerance and reliability is there, and the input of performances, flexibility and modularity, and geographical distribution. What is called by geographical distribution? It means in a system. In what is the main thing is distributed architecture? Distributed architecture mean the things are centralized and those are divided down to some servers. It means more servers. So if we uh, think, it mean if we think like this, we are having a main server in the Colombo, then the database server in Candy, other one is the service server is in Kurnagala, or likewise we will distribute our servers in different geographical locations. Why we are doing? If anything happen to a one location geographically, it will not affect to the whole system. So that's why geographical distribution is introduced. Then the cost efficiency, resources can be scaled dynamically, ensuring the systems only use what they need. So the cost efficiency will be reduced. So challenges of the architecture. The when you think about the name also showing distributed, it means the complexity of this architecture is little bit high. We need to design in and deploy in, maintain in all the uh, for these things we need expertise for this kind of thing. So the network dependency, there are the network dependency mean the speed of the network need to be high. Otherwise, it will be slowing our system. So the security need to be considered over this, and the consistency data consistency mean ensuring the data consistency across distributed nodes is challenging, especially in real-time applications. It mean, what is a real-time application? Real-time application is a application where when we do anything, it will be replicate as a real. That's a real-time application. So example for the distributed architecture is content delivery network. CDNs are example for this distributed architecture. E-commerce platforms are a example. Then the stream service, blockchain technologies are some examples for this distributed architecture. Okay, so distributed architecture offers a powerful approach to building modern, scalable, and resilient systems. While they come with the advantages in fault tolerance and scalability, as well flexibility to make them independent for today's dynamic and global application environment. Okay, so organizations are seeking to future proof their system must consider adopting distribute design tailored to their specific need and workloads. Anything you guys need to ask over here? Otherwise, we can go for the next slide. I think there's no. So I will go for the next slide. So uh, microservices. So microservice architecture in the is a software design paradigm that focus on dividing an application into smaller self-contained services. Each service is built around specific business capabilities, encompassing independent deployments and modular designing. So this approach enables flexibility, scalability, and fault isolation, making it ideal for modern dynamic application environment. It means so this basically this is a microservice architecture is a software design paradigm one. So this is mainly for the this will be helping by dividing the things in the small parts. So the key characteristics of microservice are independent deployment and module design. Modular designing, then we can say decentralized data management, technology flexibility, lightweight communications, and business oriented architectures. So what is a independent deployment? Independent deployment is each service is a standalone unit that can be deployed, updated, and scaled without affecting other services. It means when we hosted components on uh, different servers, it will be not affected to other service. Okay, so the independence is minimize the risk during update or patches and enabling faster time to market for new features. It means if we need to update or we can say add in a new feature, it will be not affecting to the system without the interrupt of this service. So next one we can talk about the modular design. Modular design applications are broken down into smaller modules, each responsible for distinct functionality. Example like user management or payment processing or inventory handling, likewise things. So this modular approach improves maintainability and allows team to work on individual components without interfering with other components or other service or other any part of the system. So What are the advantages of independent deployment and modular design? The advantages of independent modular will be minimized downtime, faster to development cycles, improve the fault tolerance, and scalable operations. Now we can talk about the modular design advantages. What are the advantages? Will be coming under the modular design. Enhance the maintainability, team autonomy. uh, Team autonomy mean teams can focus on individual modules, fostering specialization and reduce condition overheads. Okay, so reusability and the flexibility of innovations, those are will be the advantages with modular design and the independent deployment. So the challenges will be mostly challenges of independent deployment and modular design is increased operational complexity. Why we are saying personally we are saying the things are very easy to use. Now we are saying as a challenge increase operational complexity. Why we are saying? Because we are managing not a one, not a two, we are managing more things, more resources for this. So the operational complexity will be high. Then the inter-server communications, those are challenges, and the version management. Version management mean keeping APIs and interfaces compatible between module can be challenging during updates. Okay, because for a one server having one update, second server having another update, so this will be a challenge. So we need to update all the components into a one baseline or a one state. Then we are going to do the other updates or the feature adding or some other things we are going to before going to do, we need to keep all the system as a one baseline. So the best practice for the independence and deployments and modular design and implement API gateways, use containers and over containers and automate CI/CD pipelines and enhance loose coupling, monitoring and logs. It means centralized monitoring part should be there. It means there are some systems called Moogsoft and from the Mobitel CSM, from the Microsoft, there's called SCSM, SCOM. Those are applications which are monitor the systems of the health of these systems. It means the servers. Is those servers are up and running or the servers are up to date or other things that can be monitored. So these things need to be monitored continuously. And the secure modules individually. So they apply security based practice like authentication, encryption, and other access control should be managed. So these things will be a challenge in microservice and in microservice modular design microservices. Okay, under there we have modular design in an independence deployment. Those are the uh, best practice we need to do in those things. So examples of microservice with independent deployment and modular designs are e-commerce platforms separate module for catalog management or order processing, and payment gateway allow independent scale and updates. So stream service also example for this. So stream service uh, is designed enable distinctive service for user performances, content delivery, and recommendation systems. And the banking applications also coming under microservices. So the conclusion of this microservice is microservice architecture with its basing on independent deployment and modular design offer a modern solution for building scalable, res, uh, res, resilient and maintainable systems. By decoupling functionalities into standalone modules, organizations can innovate faster, improve fault tolerance, and efficiently adapt to evolving business need. It means if custom is requesting some future updates or something, we can update it. We can add those things easily or under microservices. So now we are going for the next slide. Service decomposition. So, service decomposition is the process of dividing an application into modular service with clearly defined responsibilities. To achieve effective decomposition into microservice architecture, it is essential to identify in here we need to identify boundaries, and we need to define APIs, and we need to maintain data isolation. These principles ensure service and loosely coupled, independently deployable, and capable of operation automatically. So the key principles of service decomposition is identify boundaries. What is called by identify boundaries? And we need to understand and delineate the boundaries of each service based on business domain or workflow. And the boundaries should align with specific functionalities or subdomains, ensuring each service focus on well-defined purpose. For example, in an e-commerce platform, boundaries could be separate the catalog, order, and the payment service. Okay, so next key components is define APIs. What define APIs mean? Establish clear and contained APIs to allow service to communicate with one another. It means it need the clear and consistent to allow service to communicate with from here to other. If you look into the image which is shown in the slide, it's showing when we Microsoft someone, the communication need to be done bi-directionally. If he is doing something, it need to be replicated over the other side as well. So example for the defined APIs, the orders service provide an API to create, update, and query order details. So next one is we need to sorry next one is we need to maintain data isolations. What it will each service should have exclusive ownership of its own data, avoiding shared database. It mean the detail if you guys know, or if you guys have create a table or a level 1 structure, there we are define if you have designed a diagram, we are using primary key or a secondary key or something to avoid the duplication or avoid the conflict of databases. Is it clear? So this isolation enhance security, prevent data inconsistency, and enable independent scale of service. Like the payment service manage transaction record independently of the order service. So when this is mainly we are doing by when we creating diagrams. So steps for effective service decomponent: identify boundaries and define APIs, maintain data isolation. How we going to do? I analyze the business domain and workflow to define service boundaries. Use domain driven design DDD to identify cost supporting and generic subordinates and group related functionality into units. For example, in a ride hailing app, core boundaries will be ride booking. So the supportive, what will be the supportive boundaries? Supportive boundaries will be driver matching service, and the generic boundary will be authentication service. So when we come to the define APIs, uh, design the lightweight and well-structured APIs for each service. Use REST, REST, or gRPC or graphic QL for communicating. Ensure APIs uh, encapsulated service logic and expose only necessary functionality. For example, the inventory service provide an API to check the product availability, inventory check. Then when we update the stock levels, inventory and update. So, what are the benefits of these principles? I didn't benefits will be enhance modularity by grouping related functions together, align services with boundary goals, making system easier to adapt and extend, and facilitate seamless communication between services or provide a clear contract for service interaction, reducing integrated issues. So challenges over the what will be a challenge? When we identify the boundaries, challenge will be poorly defined boundaries can lead to tightly coupled service or redundant functionality. When we design an API, define APIs that are flexibility yet stable requires careful plan and uh, strategies. So the constantly data constantly, what will be the challenges? Maintaining the consistency across isolated data stores can be challenging, especially in real-time systems. So for the best practice, how the boundaries will be continuously defined services, boundaries based on business workflow and usage pattern. For APIs, designing APIs with clear input-output specifications. What it mean? It mean in the we need to clearly mention the this is for this requirement. This is for this requirement. And the data isolation will be employ event-driven architectures for synchronized update between services. For example, for the decomposition, e-commerce platforms like catalog services, uh, order services, stream platforms, content delivery service recommendations, likewise things. So when we come think about the effective service decomposition is a cornerstone of microservice architecture. By focusing on identifying boundaries, define APIs, and maintaining data isolations, organizations can design systems that are modular, scalable, and resistant. While the process introduces challenges like handling data consistently and managing inter-service communication and adherence to the principles ensure a robust and adaptive systems. So next we will talk about the containerization. So the containerization is a transformative technology that packages applications and their dependencies into lightweight, portable units called containers. So containers ensure consistency across development, testing, and production environment. So there are two central tools which is in this ecosystems are Docker and Kubernetes. So the Docker is the foundation of uh, the containerization. So the key features will be uh, container creations, portability, image management, and efficiency. For the Docker workflow, write a Docker file to define the applications and its dependencies. For examples, for developing a web application, is we can define the Docker file from the nginx and likewise. So these will be, I will for the examples I will put over the chat as well. So this I will put this one over the examples I will put over the chat. Just go through it for you guys. Uh, just a moment. After the slideshow and other lecture, I will put this on, okay, over the chat for you guys. So, n- so the challenges and consideration over this containerization is complexity, resource management, security, and monitoring and login. So, the why complexity is a challenge for this one? Because Kubernetes has a step learn curve specialized for managing large scale clusters. That's the main challenge over this for the complexity. So the other one for the we need to secure the container images and the uh, orchestration layers. Example, for the role-based access control should be integrated. For the best practice of the Docker, use minimal base image to reduce attack surface and image size. Then scan container image regularly for vulnerabilities. For the Kubernetes, define resources limits in pod specific to avoid overuse of resources. And the leverage namespace for logic isolation and workloads. So the Docker and Kuber, uh, Kubernetes are independentable tools in modern software development. So that's why I'm not going to talk too much about this. This is mainly for the software development side. Okay. So now we will come to the serverless computing. So what is serverless computing? In here, no need to manage servers. We can pay as we use, and other. There are so many advantages. So mainly, serverless computing is cloud computing. So serverless computing is a cloud native model that allows developers or system engineers to build and run applications without managing the underlying infrastructure. Instead of provisioning, scaling, and maintaining servers, developers focus slowly on writing code while the cloud provide automatically handle resources, allocation, and operations tasks. So the key components of serverless computing is function as service fast. We are telling FAAS. Applications are broken into discrete functions triggered by specific events. API calls database like database changes. So the infrastructure mean the cloud manages all backend operations, including server provisioning, scaling, and maintenance. This is done by mainly from the cloud provider. So we can event-driven architecture. Sorry. So the serverless applications respond to events such as HTTP request or file upload, uh, eliminating the need for persist server process. And the pay as you go pricing. It means we only pay the things we are only use. So the billing based on the actual usage, and it will reduce the cost for idle resources which are not used. How serverless computing works. So for the code development, developers will write function and deploy them to a cloud provider serverless platform. So the event triggers functions are executed when a specific event occurs, such as an HTTP request, a message in queue, or database update. So then automatic scaling means the platform dynamically scale resources based on demand, ensuring optimal performance. These are some features inside the cloud computing or serverless computing. If we talk about on-premises, these are need to be scaling the things need to be done by us. But when we think about the serverless, it will be done from the cloud provider. So the popular serverless platforms are AWS, Azure, Google Cloud, IBM Clouds. Advantages of the serverless computing is reduce optional overhead, scalability, cost efficiency, faster time to market, enhance resilience. And one thing I need to tell about, if you are going for the serverless computing architecture, there should be it's a mandatory requirement is internet, because without internet how can we communicate, or how can we use this cloud service? So internet is a must thing in the serverless computing. So the challenges of serverless computing: cold starts legacy, vendor lock-ins, limited execution time, debugging complexity, state management. So when we think about the serverless architecture and traditional architecture, what is called by traditional architecture? Traditional architecture is the on-prem architecture which we are using servers, physical server. Serverless is a cloud-based solution. So feature serverless computing traditionally architectures infrastructure managed by cloud provider, and the scaling automatic and dynamic manual or written by written predefined. Okay, so so when we think about the web application, the build scalable APIs and web applications with reduced overhead. Real-time data processing, streaming data and IoT devices or logs in real time. So, what are the best practices of the serverless computing? The designing for statelessness, optimize function performances, monitor and debugging, adopt security measures, leverage CI/CD pipelines. Most of these things are provided by cloud provider. Okay, so when we come to the conclusion of serverless computing is revolutionize how applications are built and deployed by abstracting the infrastructure management and enabling event-driven workflow. Okay, with the platforms like Docker and Kub- Kubernetes focusing on containerized and tools like AWS, Google Cloud leading the serverless revolution. So the build is scalable and this is a cost efficient and resilient applications. So main thing in here, serverless computing is a cloud-based service and most of services are provided by the server cloud provider. And other thing is main requirement for this one is we should have internet. Okay, so next we will talk about the function as a service, which is coming under our serverless architecture. This is the power in serverless architecture. Okay, so the function as a service is a core component of serverless computing, enabling developers to deploy and execute individual functions in cloud without managing servers. So, fast abstract infrastructure and complexity, allowing team to focus on writing and running code triggered by specific events. Okay, so um, so the popular fast platforms are AWS, Azure, Google Cloud, and IBM OpenPass are some examples. And advantages of the PaaS is reduce overhead, scalability, cost efficiency, flexibility, and focus on code. Most of these challenges, then advantages, everything is very related to the serverless architecture. Okay, so fast empower developers to create event-driven, scalable applications without managing servers. Platforms like Azure, AWS, Google Cloud, and the functions which provide a robust ecosystem for developing the and running efficiently. So next we can talk about event-driven scalability. So event-driven scalability is design approach in modern architecture that enables system to automatically adjust their resources utilizations based on real-time events. This approach is fundamental to serverless computing and distributed system, ensuring high performances, cost efficiency, and reliability in handling workload. So the core principle of event-driven scalability is event-based triggers, dynamic resource allocation, statelessness, and asynchronous processing. So the key components will be event producer, event consumers, and event brokers. Also, scale mechanisms are the key components here. So how event-driven scalabilities work? So the event are captured in real time by monitoring tools, APIs, or message queues. Then they are triggering action by detected events. Invoke specific actions such as starting a serverless function or adding processing capacity. So the dynamic scaling will be the system allocate or release resources based on the volume and complexity of incoming event. So the advantages will be efficient resource utilization, improved performances, resilience, cost efficiency, and the flexibility. Challenges will be latency, complexity, and the monitoring and debugging. Also, vendor dependencies will be a big challenge for event-driven scalability. So the use case for the event-driven scalability is real-time applications like chat applications or stock trading platforms or live stream services. For the chat applications, we can talk about WhatsApp, yeah, then Messenger. For the stock trading, Binance or Bitcoin and stock market, and the live streaming service Facebook, TikTok, then YouTube, likewise things. For the e-commerce systems, handling spike during sales, event promotions, IoT workflows, data processing pipelines, serverless architectures. So, now, event-driven scalability is essential for modern applications, enabling systems to adapt dynamically to changing demands while maintaining the cost efficiency and reliability. By leverage tools like AWS Lambda, Azure Event Grid, or Apache Kafka, organizations can build responsive, resilient systems that excel under driven workflows. So now we come to the cluster computing. What is mean by cluster computing? Cluster computing involves connecting multiple computers or multiple nodes to a work together as a single system. What cluster computing involves connecting multiple computers. It means it connect multiple computers, multiple servers, multiple machines, multiple systems uh, together to work as a single system to handle large tasks or workloads more efficiently than a single machine could. So, in a cluster, each node may be responsible for a part of the processing, sharing the workload, and improving performances, reliability, and scalability. So, when we talk about the cluster computers, it means the cluster server, cluster architecture. So, in a one machine, there will be so many other machines like virtualization happening on Hyper-V or something. The cluster, we are using cluster mainly if one cluster is failed, the other cluster will be up and running by giving the high availability to the system. Okay, so key concepts of cluster computing, including parallel processing, fault tolerance, and load balancing, as well as scalability. Sorry, scalability and high availability. Also, it will be shared. The storage of the cluster will be shared by them. So, mainly when we talk about the applications of cluster computing, including high performance computing, big data analyzing, and distributed databases, web hosting, and cloud services, as well scientific uh, simulations. So, this cluster computing mainly come in because main reason of this is high availability to give the high availability of the system. So, in the industry, what we are doing, we are using uh, two clusters for one. I'm telling you one example. Um Over the two clusters, if we need to do something over a one cluster, what we are doing, we are moving all the VMs or all the systems which are run on the cluster A to cluster B, and we are doing the performances. So we are shut down in the mesh that cluster or some any process for the cluster A can be done without uh, down in the system. How we are doing? We are moving all the VMs or all the systems for the next available cluster. Okay. So it will be giving the high availability. So now we will talk about the HPC. HPC mean high performances computing. What are the high performances computing? It refers to the use of powerful processors, parallel processing, and advanced computer architecture to perform complex calculation at a high speed. Mostly, we are telling this as supercomputers, super servers. So, key characteristics will be uh, parallelism and the supercomputers, distributed system, specialized hardware, scalability, and the storage and data management. So the applications of HPC will scientific simulations, artificial intelligence or AI, machine learning, or medical research and engineering, as well as big data analysis, quantum computing. Most of these HPCs are available over NASA and other companies, or the where the things are going high speed. It mean maybe FBI, CIA, Pentagon, as well as in Sri Lanka, most of our intelligence services, they are using these HPCs because they need to analyze data more effectively and quicker. So the HPC softwares, uh, mainly HPC softwares will be MPI, message patient in interfaces, OpenMP, CUDA, Computer Unified Device Architecture is called CUDA, and the Spark and notable HPC systems. So the HPC is central to avoiding HPC is a central to advising technologies and knowledge in a wide range of fields. Okay. So, do you guys have any question over this? Anything you guys need to ask? Guys, just talk. Otherwise, I am getting bored over there. So next, we can come to the load balancing techniques. So the load balancing is a critical technique used in distributed system to distribute incoming network traffic or compute computer computer workloads across multiple servers or resources to optimize performances by preventing any single resources from becoming overload or ensuring high availability and reliability. So the round robin is how it works. It requests a distributed in a sequential order across the available servers. Once the last server is in the pool receives the request, it loop back to the first server. Some use case is this is one of the simplest and most widely used techniques suitable when all servers have roughly equal capacity and load is relevant uniform. So the advantage will be over the round robin, simply to implement and effective for equal resource distribution. The disadvantage will be doesn't consider the actual load or capacity of the each server, may cause some servers to be overloaded if they have different performances characteristics. Next one will be least connections. What is least connection? Least connection direct request to the server within the fewest active connection. How it works? This method directly incoming traffic to the servers within the first activity connection. It's ideal for systems where the time it takes to process request varies significantly. Use case of this useful when workloads have varying processing times, like web applications where some users may require more resources than others. Advantages of least connection is more dynamic and responsive to real system load. Disadvantage requires more complex monitoring and real-time tracking of server connections. Next one will so other over the random we can come to wait round robin, IP hash, then the least response time, random load balancing, and global load balancing. So there are also another method called hybrid load balancing as well. Over the hybrid load balancing, a combination of different load balancing techniques can be used in tandem, depending on the application needs. For example, wait round robin might be combined with the least connection or round robin to balance both resources available and the number of activities connection. It means the over the load balancing method, if two or more are connected together, it's a hybrid one. How we choose the right load balancing technique? By uniform load. If requests are uniform and servers are equal, round robin or weighted round robin is often sufficient. If a variable load for the systems with varying resources demand, techniques like lead connections and least response time or dynamic load balancings are equal. Those are little bit some how we need to identify which load balancing is going to use. Okay, so now we will come to the cloud native architecture. So this is the what it called. This is the base. It means the modern approach in the industry cloud. But previously also I have explained in Sri Lanka we cannot go complete cloud, but you guys need to take deeply, understand deeply this cloud concepts, because this is the modern approach. In the future, most jobs will be available for the cloud. So cloud architecture. Cloud native architecture refers to design system specifically to leverage the cloud scalability, reliance, and flexibility. It embarrassing the Microsoft's containers and modern development practice for agile, efficient, and deployment of the management. So, the core principle of cloud native architecture is microservice, containerization, DevOps, and automation, scalability and elasticity, and resilience, APIs, and event-driven communications. The key technologies in cloud native uh, encapsulate apps code and dependency, Docker, Podman, orchestration, manage development, scaling, and operations apps. Okay, so the benefits of cloud native is mostly space, speed, flexibility, cost efficiency, reliance, and global reach. What mean by global reach? Global reach mean if we have internet, we can connect to the cloud anywhere with the internet. So it's the name. That's why it's saying global reach. So, why cost efficiency? Why we are saying benefit as a cost efficiency? We only pay as you go model. It means we are paying only the resources which are using by us. Okay. So the best practice of cloud native design is start small, embrace infrastructure as a core, design for failures, monitoring everything, prioritize security. So challenges in this by to adopt for the cloud native architectures, complexity and skill gaps, migration issues, cost management. Complexity. What is mean by complexity as a challenge? Managing many microservices require robust orchestration and monitoring tools for this. So the skill gap. What mean by skill gap? That's the thing I have already told. The teams need expertise in cloud native tools and paradigms. That's why I'm saying just go deep over the cloud computing as you can, because this is the future. And the migration is, what is by migration? Migration mean where if we need to migrate on-prem machine, on-prem service server to cloud, it will be a challenge because less skill are there, and the complexity also refactoring monoliths into microservice can be resource intensive. The cost management. The misconfigured scaling or over provisions can be lead to a high bill, because we pay what we are using. If we misconfigured something, or if we used something we don't know, the cost will be high. So those are challenges. So this is happening due to less skill gaps. Okay, so the conclusion of the cloud native architectures represent a transformative approach to application development, offers unparalleled agility and scalability. So now we come to the IaaS, infrastructure as a service, building blocks of cloud. So what is called by as? Yes, IaaS is a cloud computing model where business access fundamental computing resources such as a virtual servers, storage, and networking over the internet. Okay, so it eliminate the needs for maintaining on-prem server data centers, while offering flexibility and scalability for modern workload. So the key features will be virtualized resources, scalability, then the pay as you go, because over the most cloud, most not most, every cloud service is pay as you go, self-service management, and global researchers. So build advantages of advantages will be reduced operational overhead. No need to manage physical hardware or data centers, because all the things will be given by cloud provider. Flexibility. The choose of which operating system we will going to deploy over the environment, or should we need to do the custom configuration. So flexibility will be available, and the reliance and the disaster recovery. Built-in redundancy and regional availability zone ensure high availability. What is called by high availability? High availability, it means this is a geo global available. So we are hosting applications over different time zones, different geographical zones. So if any geographical zone is down, other will be replicate everything and give the service. These services will be provided by the cloud provider. So another one is main thing is global accessibility. It mean if we have internet and if we have the IaaS service, we can use it wherever we are by internet. Okay. So use cases of IaaS: hosting websites and applications, big data analysis, disaster recovery. This disaster recovery will be given by Microsoft. Sorry, the Microsoft or Azure or the Google, the person who is providing the cloud computing service will be giving the disaster recovery. So we no need to think about it, because on prem, if we think about the on prem one, we need to create a DR site as well. So the DR site will be handled by the cloud provider. So the development and testing will be use cases. The challenges will be cost management, complexity, security concerns, vendor lock-ins. Because this is a concept, this is the theory, this is the place where we are not having any physical things. All the services and all the things will be provided by cloud provider. So the best practices for the IaaS is right size resource allocation, automated infrastructure, monitor and optimization, secure by design, plan for scalability. And IaaS and other cloud modules will be IaaS is full control over the infrastructure by the cloud provider. Okay. So the Azure end users protect productivity tools like AWS EC2, Azure VMs, Google Apps Engine, Azure App Service, Office 365 likewise are there. So the conclusion, IaaS layers the foundation for the cloud adoption, offering unparalleled control, flexibility, and scalability for the business. It empowers the organization to focus on innovation while the cloud provide manages the physical infrastructure within the strategic plan and best practices. IaaS can become the cornerstone of the modern IT strategy. Got it? Anything over this one? So next one will be the virtual machines. What is virtual machine? VMs, building blocks of IaaS. So what is a virtual machine? Virtual machine are software-based representation of physical computers. They emulate hardware components, allowing multiple operating systems and applications to run on a single physical machine. Leveraging resources optimization and enabling simple deployment infrastructure. This is the thing we are going to do on the our workshop. We are installing an application of our normal machine, and we will be hosting various virtual machines over in our physical machine. Okay. So the virtualization technology created using hypervisor, which is abstract physical hardware and allocate virtual resources. There are two type of hypervisors. Type 1 is bare metal, type 2 is hosted. So the second characteristic will be isolation. Each VM's operations independently within its own OS and applications, providing security fault isolations. Then the resource allocations we can do portability. Portability means we can carry this VM from this machine to another machine as a portable one. So the components of the virtual machines will be virtual CPUs, virtual memory, and virtual storage. But if we are saying these are virtual, but actually these virtual things will be taken from the memory is CPU and the space from the physical machine. Okay. So the benefits of this virtual machine is resource optimization, simple development, cost saving. Why we are saying cost saving? From a one physical machine, we will be creating more machines in a one physical machine. So the cost will be allocated to one physical machine, but the resources will be more resources will be inside that physical machine. So cost will be saved. So isolation will be can be done. Disaster recovery can be done by taking the backup or restore entire by getting a snapshot or a checkpoint or something like that. There are some various kind of backup mechanisms over the VMs. So, challenges of virtual machines will be performances overhead because we are using the physical machines resources, and the management complexity lies in cost, and security risk will be there. Best practice for the virtual machine deployment is right size resources, automation, regular monitoring, snapshots, and backup management, as well as security hardening. So the conclusion of virtual machines are the cornerstone of IaaS, offering flexibility, resource optimization, and simplified deployment. While containers are gaining traction for cloud-native applications, VN remains indispensable for legacy system, multi-OS requirements, and isolated environments. So, next we come to the elastic resource provision, scaling on demand. It means resources will be the elastic mean what is mean by elastic? Elastic mean it's stretch. So the resources will be allocated to here as per the demand. It will be scaling the things as per the demand. So, elastic resources provisioning refers to the dynamic allocation and deallocation of computing resources based on workload demand. This capacity enabled by cloud computers ensure optimal resource utilization, cost efficiency, and consistent application performances, especially under fluctuation demands. Key characteristics will be dynamic scaling, on-demand flexibility, pay-as-you-go mode, multiple dimensional scaling. Benefits benefits of this cost efficiency, improved performances, reliance and reliability, resource optimization, and global scalability. So the action, it mean the elastic resources provision in action. It mean e-commerce sites like automatically scale during sales event or seasonal spike to handle increased traffic. Streaming service adjust the bandwidth and computer resources dynamically based on viewership, big data and analysis. Scale computer nodes to process large dataset during data pipeline or analytics runs. It mean in the industry, there's some product called Citrix. Okay, in there, what they are going to do, what they are doing, they are hosting applications over a one machine, and they are scaling those things to stand by 10 machines. If the availability mean the request is high. The users will be high who are using the application. By automatically machines will be allocated to users. If the usage is low, the machines will be coming down. It means shut down. The applications will be automatically shut down and machines will be automatically start up as per the requests. Okay. So the the conclusion of this elastic resources provision empowers organization to handle dynamic workload efficiently and ensure optimal performances and cost saving. As a business continue to adopt cloud native strategies, mastering elastic provisionings become essential for scalability, agility, and resilience in the competitive digital landscape. Okay, so next we will talk about platform as a service, PaaS. So, platform as a service. This is a cloud computing module that provide a fully managed environment for the developers to build and deploy and scale application without worrying about the underlying infrastructure. It bridges the gap between IaaS and SaaS. It means infrastructure as a service or a software as a service. So it offers tools, runtime environment, and services tail over to application development. The key features will be managed infrastructure, development frameworks, and integrated tools are there. Auto scaling, multi-language supported. Benefits will be simplified deployment, cost efficiency, built-in scalability, and innovation focus. So the components of a PaaS environment will be managed runtime environments for the application executions. Okay, so the example for PaaS uh, providers key features popular services AW Elastic, Beanstalk, automatic deployments, scaling and monitoring, Beanstalks, RDS, Microsoft Azure App Services. So, advantages of PaaS will be rapid development and deployment, enhanced collaborations, integrated ecosystem, reduced complexity and agility and scalability. Challenges over here will be vendor lock-in. Vendor lock-in means applications may become tied to specific task provider due to proprietary service or APIs. Customization limitations, performances variability, security concerns. So conclusion of the past is revolutionize the way applications are developed and deployed by abstracting infrastructure management and offering a streamlined development. Ideal for developers for business aiming to accelerate innovations. PaaS provide the tools and scalability needs for the modern applications. So next we can come to the manage runtime environment, streamlined code executions. Manage MR, MRES provides developers within a fully controlled platform where code is executed seamlessly without the need of managing underlying infrastructure. Okay, so these environments abstract away the complexities of hardware or operating system or runtime dependencies. So the key features will be abstracted infrastructure, automatic scaling, language and framework supports like .NET, Python, Java, Node.js, likewise things, integrated monitoring and lagging, also cost efficiency. This is Most of cloud are cost efficiency, because why we are saying cost efficiency, we are going pay as you go. So the benefits will be simplified code deployment, focus on business logic, improved reliability, and environment consistency. So the use case for the managed runtime in environments, event-driven applications like HTTP requests, database updates, or IoT events. Microservice like deploy modulars independently managed service for modern architecture. And data processing like ETL, extract, transform, load task for the processing, streaming data in real time. Then chatbots and APIs also integrated with this. The automation are also a part of this. The challenges of managing runtime environment is cold start, vendor lock-in, limited customization, debugging complexity, and cost management. So the conclusion will be managed runtime environment offer a streamlined approach for the code execution, empowering the developers to deliver high performing applications. So next, auto scaling capability, dynamic resource management. What is automatic scaling capability mean? Automatic scalability mean it that example which I have told you guys, the VMs or the services are will be automatically adapting with the request. It means capabilities allow applications to dynamically adjust. If the demand is high, request is high, the allocations of things will be automatically scaling. If the things need to be the request and the other things will be low, the it will be automatically reducing the things. So the cost optimization will be happening due to the automatic scaling, because if we are not using, it will be optimizing the cost. So for the next one, next one will be microservice architecture, containers and or containers and orchestration. Microservice architecture. Microservices contains allow applications to be broken down into small independent components, making development, deploy, and scale more management. Then the orchestration tool like Kubernetes manage the deployment, scaling, and networking of containers automatically, complex tasks, and ensuring applications availability. These things already we have discussed previously, so I am just going by taking one by one telling. Then the cloud native will be constantly and or orchestration are core components of cloud native architectures, enabling the creation of high scalable, resistant, and adaptive applications. These things we have already talked previously. So I will go for the Docker containers, packaging, and runtime applications. So Docker containers are lightweight portable units of software that package on applications and all its dependencies into single isolation environment. By standing the runtime environment, containers ensure that applications run consistently across different computing environment, whether on a developer's laptop or a private data center or a public cloud. So the key features will be isolation Portability, efficiency, modernity, version control, and built-in network. How Docker contains work. Step descriptions build. Developers create Docker files, specific applications, dependencies, and configures. So the packages will be the application and its dependencies are packaged into a container image. These things, Dockers and other things we have explained. I just going through lightweight and portable, these Docker containers, and the simplified deployments, enhancement, scalability. There are these things we have already talked. The same thing. The difference is this is in apart from the cloud on-prem. This is integrated to cloud. So that's why I previously also I have said we need to consider the on-prem things. First, we talk about the on-prem thing. It was replicated to the cloud. So the same thing is available here. The difference is we have given pay as you go. So the so the Docker containers are revolutionized and the way applications are developed, tested, and deployed offer unmatched probability, consistency, and scalability. So the managing contains applications will be these are Kubernetes, Docker, Azure, Google Cloud, AWS. So are there anything you guys need to talk about? And this is the uh, end of the lecture 2. Next week I will continue other architectures. There are another other three architectures, main three architectures we need to talk. It will be conducted by next week. So are there any questions for you guys? I think no one having issues. Just go through with the session again. If you guys having any issue, just contact me. Okay. So if there's